So our first key is for the 10 local native conifers. So I discussed in another video that conifers are cone-bearing. Conifers have cones, and they have reduced leaves, needles. And in the North Bay area, we only have about 10, maybe 11 species of conifer. There's not as much diversity of conifer as there is diversity of broadleaf trees. This is a dichotomous key for the local native conifers, so it's only going to be the conifer trees from the wilderness of North Bay. It's designed for nipissing students walking through the woods in the North Bay region. It should work for most of the trees that you can find around Ontario, as long as they're from the forest and not your backyard. It doesn't have things like blue spruce and Scotch pine, which are really common backyard species. A dichotomous key, di, means two. It has two options, so we get to choose. Our first one is, are the needles scale-like or are they linear? So this is a scale-like. This is an eastern white cedar. These needles aren't very needly. They're kind of scaly. And junipers and cedars all have this kind of scaly needle. If you're in southern Ontario, you might have junipers or eastern red cedars. We should pick a tree and try to ID it. Let's do this one. So if we were to choose whether those have scale-like needles or linear needles, what would we choose? So I'm going to take this, bring it up close. Come on, focus. You can do it. There we go. If I can pull some of these off and put them down, you can see these are linear needles, so we don't have a cedar tree. Our next one is asking, are the needles single and in clumps of 10 on the same twig? Or the needles clumped or single, but not on the same twig? So I don't have the tamarack twig here to show you, but you can see that the bundles are greater than 10. They're massive, and they're super soft needles. This is a deciduous tree. Tamaracks lose their needles in the winter, so the needles are quite soft. Most bundled trees only have a few needles in their bundles, but the tamarack has more than 10. So if we don't have a tamarack, we're going to keep going because this is all linear. There's no bundled needles. So our next one is asking, is it always single or is it always bundled? Because if it's always bundled, you have a pine tree. And I know colloquially a lot of people call every single evergreen tree a pine. But to a biologist, pines are only the needles, trees with needles in bundles. So if I pull the needles off of here, they come off in bundles. This is a pine. And we'll get back to what kind of pine that is in a minute. But because they're bundled, we know they're a pine tree. Ours doesn't have bundles. They came off all single. When I rip them off, they all come single. So, I gotta move the needles here. Are the needles green underneath with flat and pointed ends, or do they have whitish lines underneath? So I'm gonna bring this up. Hopefully, oh yeah, you can see it. Can you see those two white lines on the bottom? And the ends are rounded. This is not a Canada yew, Taxel canadensis. So our next question is, do the needles come in a 3D arrangement, 4-sided needles in a 3D arrangement, or 2-sided needles in a 2D arrangement? So if we look at these, and I turn one on its side, you can see that these are flat needles in a 2D arrangement. If I took a needle off and I held it in my hands, they're very flat. I can't roll them. So that is either a fir or a hemlock. But if you have 3D arrangement, you have a spruce. I'm going to show you. I brought a spruce with me. All the spruce trees, there's lots of different kinds, they all have their needles in a 3D arrangement. Can you see that? the needles go all the way around. And if I pull some needles off, they're four-sided, they're almost round. So I can roll them between my fingers. You can't even see it. The needles are so small on this spruce. I can roll them between my fingers. Four-sided needles in a 3D arrangement is a spruce. So you can see them side by side. The spruce has more texture to it. It's pricklier. This is quite flat. So this is telling me, these little asterisks here, there's one at the pine, and there's one at the spruce, and one at the fir and hemlock. That means there's more information. So what I'm going to do is I'm going to flip this page, and on the other side, it has a more specific key. So it does the pines first, and then the spruces, and then the fir and hemlock. So we're just going to look at the fir and hemlock to start with, because that's our mystery tree that we're trying to figure out right now. So to tell if you have an eastern hemlock or a balsam fir, there's two different things, and they both require pulling the needles off. So if I pull these needles off and I put them down on this ruler down here, you can see that generally they are a centimeter or smaller. So needles less than 2 centimeters and attached by a thread-like stalk. I'm going to show this to you close up. Hopefully. Can you see those little threads coming off the needles? This is hairy hemlock. Balsam fir have needles that are greater, and I happen to have a balsam fir here. So if I pull my balsam fir needles off, and I put them down here, and I start to measure them on my ruler, they are all greater, even the tiny ones, because balsam fir has a lot of diversity in its needle length. But even the tiny ones are more than a centimeter long. And if I put them on my hand with my fir needles, maybe you can see that they have little feet, little balls on the ends of their needles. So we call them hairy hemlock and bally balsam. That's how we tell those apart. I also see the white lines on the bottom of the hemlock are much more distinct than the white lines on the bottom of the balsam fir. You can still see those two little white lines, but they're not nearly as distinct. Balsam fir, eastern hemlock. So let's go back for a second to our spruces, because there's two spruces in the North Bay area. In some parts of eastern Ontario, like if you're near Ottawa or Cornwall, you might have red spruce. And there's a lot of crossbreeding. So you might have a hard time telling whether you have a white spruce, black spruce, or red spruce. But again, needle length is one of the key identifiers. These needles, oh my God, they're not coming apart. These needles are again a centimeter or less. So here it says needles less than 1.3 centimeters is black spruce, needles greater than 1.3 centimeters white spruce. One of the ways I tell black spruce from white spruce is if I'm in a wetland, I probably have a black spruce. If I'm upland, I probably have a white spruce. I picked this in a wetland. The needles are less than a centimeter or centimeter or less. This is probably a black spruce. If I had picked this tree in an upland and I had longer needles, I would assume it was a white spruce. But this one's a hard one to do. Spruces are a little bit tough. Pines are a little bit easier. Pines, like this pine, you count the needles. So here I've got 1, 2, 3, 4, 5 needles in a bundle. That's a white pine. The word white has 5 letters. 1, 2, 3, 4, 5. So white pine. White pine needles are also quite soft and fine. The other two pines that we have locally are red pine and jack pine. Red pine needles are very long and they're thick. They're way thicker than a white pine needle. Like you might be able to use a red pine needle as a toothpick, but you couldn't do that with a white pine. They're much too soft. Jack pine needles are quite short and they twist away from each other. Do you see that? They're twisty. My ecology teacher used to say that jack pines are twisted because they drink too much Jack Daniels. but even the cone is twisty. A red pine cone is a circle almost. A jack pine cone has a twisted end on it. And they're usually waxy and tightly closed. All right, those are the conifers.